geometric sequences. And again, it's a list of items, but this time instead of having a common difference, something that you add or subtract to get from one item in the list to the next, these sequences are going to have what's called a common ratio. And a common ratio is a value that you're going to multiply one item in the list by to get to the next item in the list. So if we look for, or if we look at our example that I have here, to get from the first item in the list to the second item in the list, we had to multiply by 2. To get from the second to the third, we multiply by 2. To get from the third to the fourth, we multiply by 2. So many of the same notations are going to be used in this sequence as well. A1 is 3. The common ratio, so we're going to use an R this time, is a 2. And we can find multiple terms in this list as far out as we want to. And in order to do that, we're going to have to use a formula as well. The formula that we're going to use to help us find our sequence, we'll have to use exponents though, because you're repeatedly multiplying by the same amount every time. We need to know how many times we're repeating or we're multiplying by. So in this case, we're multiplying, by 2 the same time. How many times do we multiply by 2 depends upon how far out we want the sequence to go. So our formula for finding any term in a geometric sequence will be a sub n. And again, a sub n is the value of the item in the list that you're looking for. A sub 1 is going to be the first term. And that first term is going to get multiplied by the common ratio raised to the n minus 1 power. So if I want to find the 16th term, that means I'm going to multiply that common ratio together 15 times. Here I found the fourth term, and I only needed to multiply by a 2 3 times. So that's why it's n minus 1. So if I told you that I wanted to find the 14th term in the list, and let's just use the same values that we have started here so far. So I want a sub 14. The first term in the list is 3. The common ratio was a 2. And I want to multiply 2 together 14 minus 1 times. Well, 14 minus 1 is 13. And then when I do that, I want to times it by the first one number, which was a 3. Whoops, this should be a 13 also. So hopefully my calculator will do this all right. 2 Okay, so on this calculator to do powers, I would take 2 and raise it to the 13th power. I get 8,192, but then I have to multiply that by 3, the first item in my list. So the 14th term, and I forgot what it said, is 24,576. Now, wow, that's only the 14th term. You might be surprised, but remember, we're multiplying. Every number got doubled every time we did it. So that is going to cause these numbers to jump up to high numbers pretty fast. Okay, so let's get rid of some of this and do some other examples here. I'll put the formula back up here. A sub n is equal to the first term times the common ratio raised to the n minus 1 power. So let's say we have a common ratio that's not necessarily a whole number. We didn't do that with any of our arithmetic sequences. So let's say that our first term is 128. Our common ratio is a half. And we want to find, let's find the 10th number in the list. Okay, so we're not going out very far, but with the halves, I know that you don't always like to multiply by halves. So 128 is the first number. The common ratio is 1/2. And we want to go out to the 10 minus 1 power. Well, 10 minus 1 is 9. So we need to multiply 0.5 together 9 times. 0.5 is going to be raised to the 9th power. It's a really small number, and then we're going to multiply it by 128. Whoops, I think I multiplied it by 18. There we go. Got to make sure we get all those numbers. So the 10th number in the list is 0.25. Cutting the values in half every time. Okay, so the first time we would have done 128 times 0.5. That would take us to 64. 64 times 0.5 is going to take us to 32. So we just keep cutting our numbers in half, and if we do that 9 times, we get to the 10th number in the list, which is 1/4. Rather than doing that 9 times, though, we can use the formula to help us get that. Okay, let's start with different information this time. All right, so this time, let's say we know the first number in the list is 8. The common ratio is 3. And we want to find the 5th term in the list. So again, we don't know the 5th term. A1 is 8. The common ratio is 3. Whoops, I don't need to put that exponent there. So we're going to raise 3 to the 4th power and then multiply it by 8. 3 to the 4th power is 81 times 8. Gets us to the 5th number in the list, which is 648. Okay. What if we started with a list of numbers? And we wanted to find out, let's say we want to find out the common ratio. There's a couple ways you could do that. Probably the easiest way, though, would be to take the second number in the list, divide it by the first. Then I would make sure that if I took the third and divided it by the second, and the fourth and divided it by the third, that I would get the same amount each time. So let's see, to go negative 16 divided by 8 is negative 2. 32 divided by negative 16 is negative 2. Negative 64 divided by 32 is negative 2. So to go from the first number to the second, I would multiply by negative 2. To go from the second to the third, I would multiply by negative 2. To go from the third to the fourth, I would multiply by negative 2. Now if I want to find the, let's find the 13th number in the list. I want to take the first term, which is an 8, times that by the common ratio, which is negative 2, raised to the 13 minus 1 power. I'm looking for the 13th number in the list, so I need to have 12 negative 2's multiplied by the first number in the list. So let's see, negative 2 to the 12th power. And I'm probably certain on some of these calculators you got to be very careful. I know on the yellow calculators, the graphing ones, you have to be careful with negative numbers. So negative 2 to the 12th power. And then I want to times that by 8. And it would be, whoops, I forgot what it was, 32,768. Let's see. There's a positive number. And so far the odd items in the list, so the first item, the third number, the third item, have been, I shouldn't say odd, but positive numbers. So that means the 13th item should be a positive. The even items, the second item and the fourth item were negatives, so any even item should have been a negative number as well. So that seems to work out just fine.